Why is it so difficult to land on the moon if we have already landed on other planets? Hey there, Insane Curiosity viewers. I'm excited to talk to you about Atlas VPN, the VPN that's taking the online world by storm and has been helping me a lot for the last couple of months. Developed by top cybersecurity specialists and IT engineers in 2019, Atlas VPN is the go-to VPN for people who care about their online privacy and security. With more than 6 million users worldwide, Atlas VPN is trusted by individuals and businesses alike. But what sets Atlas VPN apart from other VPNs? For starters, Atlas VPN is more than just a VPN. It's a powerful tool that blocks ads, malware, and other malicious links, making your online experience smoother and safer. But that's not all. With Atlas VPN, you could also access your favorite content from anywhere in the world. Whether you're traveling abroad or living in a country with internet restrictions, Atlas VPN can help you bypass geo-restrictions and enjoy unrestricted access to the content you love. And the best part? You can protect unlimited devices with a single subscription. Whether you're using a laptop, phone, or tablet, Atlas VPN has got you covered. And the deal just keeps getting better. With Atlas VPN, you can enjoy the most affordable online protection for just $1.99 per month. Plus, you'll get 3 months extra and a 30-day money-back guarantee, making it the best VPN deal on the market. So what are you waiting for? Click the link in the video description below and start using Atlas VPN today. Protect your online privacy and security while enjoying unrestricted access to your favorite content from anywhere in the world. And as always, I like to keep it real with you guys. I use Atlas VPN myself, and I can tell you that it's a game changer. I travel a lot, and I love being able to access my favorite shows and games from anywhere in the world. And knowing that my online activity is safe and secure is a huge weight off my mind. And if you are someone with the same interests as mine, click that link in the video description and get started with Atlas VPN today. Throughout the history of lunar exploration, more than half of all missions have failed. Some have been lost upon landing and never found. Others have crashed into the lunar surface, destroying themselves, and others never arrived. So why is it so difficult to land on the moon? Why didn't the astronauts on the Apollo missions have these problems? Let's find out. Although the moon is one of the closest celestial bodies to Earth, landing on its surface remains a significant challenge for aerospace engineering. The first factor complicating the moon landing is its surface. Unlike other planets like Earth, which have a dense atmosphere that can slow down the spacecraft and allow it to land smoothly, the moon has no significant atmosphere that can be used to slow down the descent. In addition, its surface is covered with craters and rocks, which increases the risk of spacecraft crashing. Another major cause of failures in missions to the moon is lunar gravity, which is only about 1/6 of Earth's gravity. This means that any spacecraft landing on the moon must be able to decelerate enough to avoid crashing, but it must also calibrate the rocket braking process well to not jump back into space. In other words, the spacecraft design and landing system must balance the need for smooth deceleration and reduced mass so that the spacecraft can remain on the lunar surface. One factor that most affects landing on the moon is the lack of real-time communication with spacecraft landing on the moon. Unlike missions on Earth, where communication can be transmitted through orbiting satellites, there are no satellites in orbit on the moon. This means that any spacecraft landing on the moon must be utterly autonomous during landing, and communication with Earth is only possible after landing. In addition, the moon has a highly variable temperature. During the lunar day, the temperature can reach up to 248 degrees Fahrenheit, while during the lunar night, the temperature can drop to -280 degrees Fahrenheit. This means that any spacecraft landing on the moon must be designed to withstand these extreme conditions and have a proper heating and cooling system that is automatically regulated. Nor should we forget that there is no GPS on the moon as on Earth. On Earth, we have the freedom to use GPS to navigate and locate places with extreme ease, thanks to which airplanes can travel without problems and land without setbacks. The Moon lacks a satellite network to provide accurate GPS signals. This means that any spacecraft landing on the Moon must rely on its navigation and positioning systems, which increases the complexity of the landing since it must rely solely on the data of that moment. The lack of atmosphere on the Moon also doesn't help, as there are no winds to help steer the spacecraft towards a safe landing zone. Instead, the spacecraft has only the rockets, which must be able to maneuver precisely in space to reach the desired area and avoid any potential obstacle on the surface that could unbalance it. On the other hand, we must also consider that a relatively small number of spacecraft have visited the Moon compared to other celestial bodies such as Mars. This means that the lunar landing experience is limited compared to other space missions, making each new mission a unique and exciting challenge for aerospace engineering. Failed missions. The Moon has been the subject of numerous scientific exploration missions that has studied its geology, chemical composition, and other aspects of its surface. This has led to important discoveries such as the presence of water in the form of ice at the poles, which could have important implications for future space exploration and the possibility of establishing a permanent human presence on our natural satellite. Most attempts to land on the Moon have failed. One of the most famous is the Soviet lunar program, which sent several missions to the Moon in the 1960s. But despite several attempts, the Soviet Union failed to land a spacecraft on the Moon before the arrival of America's Apollo 11 in 1969. Among the best-known missions of the Soviet lunar program are Luna 1 and Luna 2, both launched in 1959. Luna was the first spacecraft to pass close to the Moon, while Luna 2 was the first to impact the lunar surface. However, the first mission that attempted a soft landing on the Moon, Luna 9, was successful for the Soviet Union in 1966. On the other hand, in 1962, NASA launched the Surveyor 1 probe, which became the first spacecraft to land softly on the lunar surface. The probe returned valuable images and scientific data for several months before its batteries ran out. However, NASA has also had many failed missions, such as almost all the Pioneer program spacecraft, or the Ranger program missions from 1 to 5, which had failures mainly in the landing process and the ignition of the rockets. Another example of a failed mission was the Israeli lunar probe Bereshit, launched in 2019 to become the first private spacecraft to land on the Moon. However, the spacecraft crashed on the lunar surface due to a problem in its main engine during descent a few kilometers near the lunar surface. The far side of the Moon. Landing spacecraft on the far side of the Moon is even more difficult than on the visible side due to the lack of direct communication with Earth. On the visible side, spacecraft can communicate directly with mission controllers on Earth via direct line of sight. But on the far side, direct communication is impossible because the Moon blocks radio signals. Communication relays and satellites that orbit the Moon and act as relay stations for radio signals between the spacecraft and Earth are used to overcome this challenge. However, the precise location of these communication relays is critical, as they must be in an optimal position to provide clear and stable communication. If the spacecraft moves out of the field of view of the relay satellite, communication will be lost and the mission could be in jeopardy. Another problem is that the Moon's far side is geologically more complex than the near side, with more craters and mountains. This makes landing even more complex and requires careful planning and scheduling to avoid dangerous areas and ensure a smooth and safe landing. The problem of autonomy. Human crewed missions to the Moon have been more successful than uncrewed missions regarding the quantity and quality of data and samples collected. This is because manned missions have an advantage, and that advantage is that they can solve problems in real time by real people. In the case of human crewed missions, astronauts can make real-time decisions and adjust their strategy accordingly, allowing them to collect data and samples more efficiently and accurately. For example, on the Apollo missions before landing on the Moon, astronauts meticulously studied the terrain with measuring instruments and their eyes. Thanks to this, they could intuitively select, and only with direct observations, the best area to land the spacecraft. An autonomous craft cannot do this. In addition, astronauts can use their skills and abilities to overcome unexpected obstacles increasing the likelihood of success. On the other hand, uncrewed missions are limited by the pre-established scheduling of their operations and the inability to make autonomous decisions in real time. For example, if a spacecraft instrument fails, no one is present to take immediate action to fix it. In addition, uncrewed missions cannot make real-time adjustments to optimize data or sample collection, limiting their quality. They also rely heavily on spacecraft technology and instruments, which can be a limitation regarding the quality of the data and samples collected. If a spacecraft instrument fails during an uncrewed mission, it may be impossible to recover lost information. In addition, a spacecraft's ability to collect data and samples may be limited by its design and technology, which can limit the quantity and quality of data and samples collected. What we have learned. Despite the many technical and operational challenges associated with landing on the moon, engineers and scientists have devised innovative solutions to overcome these challenges and ensure mission success. One solution to the problem of low lunar gravity is using retro-propulsion rockets. The rockets ignite opposite to the spacecraft's motion, helping slow it down and land it gently on the lunar surface. Dampening materials and suspension systems are also used to absorb impacts and prevent damage to the spacecraft. To protect the spacecraft from the abrasive effects of lunar regolith, unique materials that are more resistant to abrasion have been developed. In addition, heat shields are used to protect the spacecraft from extreme temperature fluctuations on the lunar surface. Advanced technologies such as inertial guidance systems and GPS have improved navigation and communication, which allow spacecraft to navigate and communicate more accurately. Tracking stations have also been installed worldwide to help track and control spacecraft during missions. To land on the moon's far side, relay satellites have been launched that act as relay stations for radio signals between the spacecraft and Earth. In addition, advanced planning and scheduling techniques are used to ensure a safe landing in less hazardous areas. Space exploration is one of humanity's most remarkable feats, and the moon has been an iconic target in this adventure. Over the decades, we have faced many challenges and overcome numerous obstacles in our attempts to land spacecraft on the moon. However, these challenges have not stopped us and have inspired generations to continue exploring the universe. Despite the technical challenges and difficulties we still face in lunar exploration, we cannot help but marvel at the feats we have accomplished on the moon. From NASA's successful missions in the 1960s and 70s to the more recent efforts of other space agencies and private companies, our exploration of the moon remains a reminder of what we can accomplish when we work together to reach a goal. The moon remains a fascinating and promising target for space exploration. Space exploration has taken us to places we would have never imagined just a few decades ago, and it's exciting to think about where it will take us.